Let us begin. There is a unique stillness that arrives only when the sun has truly set, a quiet that settles over the world like a soft, heavy blanket. The noise of the day, the cars, the voices, the hurried energy of our lives finally fades. In its place, the air grows cool and the silence deepens. This is an invitation. It is a moment offered to us every single night, asking us to stop, to step outside and to simply look up. When we do, we stand on the most familiar shore we will ever know, our own small spot on Earth, looking out at the oldest and most profound ocean. The feeling it inspires is ancient. It is a mix of awe at the sheer vastness above and a deep comforting sense of home. We are small, yes, but we are here connected to this immense and silent spectacle. The first and most faithful traveller we see on this nightly journey is the moon. It is our constant companion, a silent witness to our entire history. We call its light moonlight, but we know it is not its own. The moon is a celestial mirror, catching the light of our distant sun and reflecting it back to us softened and silvered. It is a gentle light one that doesn't blind us, but instead illuminates the world in shades of grey and blue, allowing us to see in the dark. Its face is a map of time. Those dark patches which people long ago imagined were seas are not water. They are vast, flat plains of dark, hardened lava from volcanoes that died billions of years ago. They are the Maria, the Latin word for seas, and they give the moon its familiar face, the one we look for, the one we see shapes in. And upon that dusty, static surface is a story that belongs only to us. There are footprints there left by human feet. They are preserved in the airless environment, a permanent mark of our first tentative step away from the familiar shore. The moon is more than a rock. It is our anchor, the pull of its gravity gently stirring our oceans and the steady rhythm of its phases marking our months. It is the first neighbour in our cosmic neighbourhood. Looking past the moon, our eyes are drawn to other lights. Most are stars, tiny sharp points of light that seem to twinkle. But a few are different. They are steady, solid beads of light, and if we watch them night after night, we notice they do not stay fixed. They move. The ancient Greeks called them planetes, which means wanderers. These are not distant suns. They are members of our own family, our cosmic siblings, all orbiting the same parent star. We often catch a glimpse of Mars, the Red Wanderer. It glows with a faint rusted colour, a colour that tells its own story. Today it is a cold, dry, dusty world. But when we look at it, we feel a strange sense. It is a nostalgia for a past that was never ours. We know from the robots we have sent to explore it that this desert world was not always this way. We see the clear outlines of ancient riverbeds, massive canyons carved by flowing water, and the smooth flat basins of lakes that have been dry for ages. Mars is a memory of water, a quiet reminder of how precious and fragile our own blue world is. Then there is the giant. On many nights a brilliant, steady light outshines all the others. This is Jupiter the King. It is a world so large that all the other planets in our solar system could fit inside it. It is not a quiet, rocky world like Mars or Earth. It is a raging giant made of gas wrapped in swirling clouds and 1,000-mile-wide storms, including its famous Great Red Spot, a hurricane larger than our entire planet. Jupiter is our protector. Its immense gravity, its sheer size, acts as a guardian for the inner solar system. It is like a giant cosmic bodyguard pulling in dangerous asteroids and comets that might otherwise threaten us. It is a turbulent, massive and powerful sibling keeping watch from the deep. And if we are very lucky, we might see the jewel of our system, Saturn. To the naked eye, it is just another bright point of light. But even a small telescope reveals what makes it breathtaking. The rings. They are a vision of impossible beauty, a luminous flat disk circling the planet. They look solid like a halo, but they are not. They are a flowing river of billions upon billions of small pieces of ice and rock, each one orbiting Saturn independently, catching the sunlight like a cascade of diamonds. They are a masterpiece of nature, a reminder that the universe is not just vast and powerful, but also incredibly elegant. These are the sights of the night, our familiar neighbours, but they all exist, they are all visible because of one single source. When the night ends and the Earth turns, our local sky is flooded with light. The wanderers and the stars vanish, washed away by the overwhelming presence of the one star that matters most, the sun. It is our star, the centre of our family. It is the reason we have a family, Airtel. We cannot look directly at it. Its power is too great, but we live our entire lives by its grace. It is not a gentle light like the moon's reflection. It is the source. The sun is a nuclear furnace, a massive, continuous explosion of power, constantly turning matter into energy. This energy, this light and heat streams out across space and washes over our small planet. This is the true source of all our warmth. It is the energy that drives our weather, that lifts water from the ocean to form clouds, that stirs the air to create the wind. It is the source of all our life. Every blade of grass, every leaf on every tree is a small living factory designed to capture sunlight. This process, photosynthesis, turns light into the energy that forms the basis of our entire food chain. The food we eat is in its most basic form just processed sunlight. When we feel the warmth of the sun on our skin, we are feeling the direct energy from the massive, life-giving sternite of 3 million miles away. It is the anchor, the heart and the engine of our world. It is the ultimate familiar shore, the fire that warms our home, the light that guides our days, and the power that fuels all life. Now, let your mind drift away from our small familiar neighborhood. Let's zoom out, further and further, until our sun is just one tiny, unremarkable point of light. If you are lucky enough to be far from the lights of our own cities on a clear, dark night, you might see it. A faint glowing band stretching across the entire sky. It looks like a cloud or a spill of milk. The ancient Greeks called it Galaxias Kyklos, the Milky Circle. A river of light, but this river isn't made of water and it isn't a cloud in our atmosphere. It's made of stars. Billions and billions of stars so far away and so densely packed that our eyes cannot separate them. Their distant light blends together into a single hazy, shimmering glow. What you're seeing is our home, our great cosmic city of stars. We call it the Milky Way galaxy. The reason it looks like a band, a river, is because we are inside it. Imagine standing in the middle of a vast, flat forest. If you look straight up out of the forest, you see the clear sky, with only a few nearby treetops. But if you look toward the horizon in any direction along the flat plain of the forest, you see a dense, solid wall of trees stretching all around you. Our galaxy is a giant flat disk like a plate or a spinning vinyl record. We are inside that disk. When we look away from the disk up or down, we see fewer stars. We see the deep, dark emptiness of intergalactic space, but when we look towards the flat plane of the disk, towards the horizon of our star forest, we see that dense, crowded Milky Band of stars. We are looking edge-on into the heart of our own city. This city of stars has a structure much like our cities on Earth. It has a busy downtown, sprawling suburbs and a vast invisible boundary. Astronomers call the main flat part the disk. This is where we live. It's thin and it spins, rotating slowly like a colossal carousel. The entire disk takes over 200 million years to complete just one rotation. This is the suburban part of the city, and it's not uniform. It's organized into beautiful, sweeping spiral arms. These arms are not solid. You can think of them as cosmic traffic jams. They are density waves, slow-moving ripples where gas and dust get squeezed together. As the clouds of gas get compressed, this squeezing triggers new waves of starbirth. This is why the arms are so bright and easy to see. They are filled with hot, young, brilliant blue stars that light up their cosmic neighborhood. At the very center of our city is the bulge. Imagine a bright, tightly packed, almost spherical hub. This is the downtown core. It's crowded here, filled with hundreds of millions of older yellowish stars. Unlike the orderly rotation of the disk, the stars in the bulge move in chaotic looping orbits like a swarm of bees. And right at the very center of the bulge, at the absolute heart of our galaxy, lies a supermassive black hole, a quiet giant weighing 4 million times more than our sun. And surrounding this entire structure, the disk and the bulge is something else, a vast, faint, invisible sphere called the halo. The halo is the oldest part of our galaxy. It's mostly empty, but it contains faint, ancient stars. Many of these stars are grouped into globular clusters, like tiny ancient villages, each containing hundreds of thousands of stars orbiting far above and below the main city. The halo is also where we believe most of the galaxy's mysterious dark matter resides, the invisible scaffolding that gravity uses to hold our entire galaxy together. So where are we in this grand structure? Where is our sun, our Earth, our home? We are not in the chaotic danger of the center. We are not on the lonely outer edges of the disk. We are in fact in a perfect spot. We live in the suburbs. Our solar system is located in the disk about halfway out from the center, roughly 27,000 light-years away from the central bulge. We are nestled in a smaller minor spiral arm called the Orion Arm, or sometimes the Orion Spur. It's a quieter, less crowded neighborhood tucked between two of the major grand spiral arms, the Perseus Arm and the Sagittarius Arm. This suburban life is likely very important for life like ours. It's relatively peaceful here. We are far enough from the intense radiation and the gravitational chaos of the galactic center. It's a stable, calm region allowing planets like Earth to exist undisturbed for the billions of years needed for complex life to evolve. We have a perfect view of the cosmic city without being overwhelmed by the noise and the traffic. Our Milky Way is not just a static collection of lights, it is a dynamic living system, a vast cosmic ecosystem. It is constantly recycling, constantly changing. Just like a forest, it has nurseries, mature inhabitants, and the beautiful remnants of those that have passed. The nurseries of our galaxy are the nebulae. These are vast, spectacular clouds of interstellar gas and dust. They are breathtakingly beautiful, painting the dark with swirling colours of pink, blue, and deep red. Within these cold, dark clouds, gravity is a patient sculptor. It slowly, gently pulls material together. Over millions and millions of years, dense knots of gas form, spinning faster, heating up until finally deep within the cloud a core ignites. A star is born. Places like the Orion Nebula are stellar nurseries currently giving birth to thousands of new stars. These stars live out their lives. Small stars like our Sun will live for billions of years before they gently puff away their outer layers, creating a beautiful planetary nebula. But massive stars, the giants of the galaxy, live fast and die young. They burn their fuel in only a few million years and then end their lives in the most spectacular way possible, a supernova. This is a colossal explosion, an event so bright it can briefly outshine the entire galaxy. But this death is also the seed of new life. The supernova explosion blasts all the heavy elements that were forged inside the star, the oxygen you are breathing, the carbon in your muscles, the iron in your blood, out into space. This material, this stardust, spreads through the galaxy. These are the supernova remnants, expanding glowing clouds of recycled material. This stardust mixes with the hydrogen gas in other nebulae, enriching them. This enriched material then forms the next generation of stars, and just as importantly, it forms planets. And on at least one of those planets that stardust learned to think, you are quite literally made of the remnants of exploded stars. The galaxy is a closed system of birth, life, and rebirth, a continuous gentle cycle playing out over billions of years. Nothing is wasted. You are the universe becoming aware of itself. Just relax and feel that connection. You are a part of this grand cosmic city. Let us continue our journey. We have seen the beautiful lazy spiral arms, the nurseries where new stars are born, and the quiet spaces in between. But now we set our sights on a new destination. A place of legend, a place of mystery, a place of immense power. We are going to the heart. We are going to the center of our galaxy. Breathe in, and as you breathe out, let your mind drift. We are leaving the familiar suburbs of the Milky Way. Our imaginary ship turns inward toward the great glowing hub that we can only see from Earth as a faint smear of light hidden behind clouds of dust. The journey is long. We must travel thousands upon thousands of light years. A light year, as you know, is the distance light itself can travel in one full year. It is a distance so vast our minds can barely hold it, and we must cross many thousands of them. As we get closer, the view begins to change. The stars are no longer spaced so far apart. The dark, empty blackness of space is less empty. We are entering a region that is crowded, busy, and ancient. We must first pass through the great veils. Imagine flying through clouds not of water, but of cosmic dust and cool gas. These are the dark lanes we see from Earth, the patches that block our view of the center. In our mind, our ship glides through them safely. They are dark, reddish-brown, and enormous. They are the raw materials for stars that have not yet been born, and the dust of stars that died long ago. We push through these veils like pulling back a thick, heavy curtain, and what we see on the other side is breathtaking. We have arrived at the great central bulge. It is not a flat disk like the arms we left behind. It is a vast, round, densely packed sphere of light. If the spiral arms are the quiet countryside, this is the most crowded city you can possibly imagine. A city of stars. The light here is different. It is not the bright, sharp, bluish-white light of the young hot stars in the arms. This light is older. It is a deep, warm, golden and reddish glow. This is the light of ancient suns. The stars here are the elders of our galaxy. Many of them were born 10 billion years ago, perhaps even 12 billion years ago. They are the first generation. They have seen almost the entire history of the Milky Way unfold. They watched as the spiral arms formed. They watched as our own sun, a latecomer, a child, sparked into life far away in a quiet suburb. These old stars are packed together 1,000, even 1,000,000 times more densely than in our own neighborhood. If you could stand on a planet here, which is unlikely as the chaotic gravity would make it hard for a planet to survive, but if you could, the sky would be terrifyingly beautiful. There would be no night. The sky would be a solid blaze of light brighter than 1,000 full moons on Earth. It would be a ceiling of countless brilliant suns so close they would look like jewels sewn onto a golden cloth. The movement here is not the calm, orderly rotation of the spiral arms. The stars in the bulge move in all directions. They swarm. They fly in long, looping elliptical orbits like a frantic swarm of bees, all held together by a central invisible gravity. It is a place of beautiful, luminous chaos. We move through it, our minds wide with wonder at this ancient, glowing metropolis. But we are not yet at the centre. We are only in the surrounding city. We must go deeper to the very core, to the final address at the heart of it all. The density of stars increases. The light becomes almost blinding, a sea of gold and red. The pull of gravity is immense, guiding us, pulling us toward one single unseen point. The stars around us are moving faster now. We can see them even in our imaginary journey, whipping around an invisible centre at incredible speeds. We are looking for something we cannot see. We are looking for the king, we are looking for the anchor. We arrive at the very heart. It is a place called Sagittarius, a star. It is a name given to the precise centre of the galaxy. And what is there? Nothing. And everything. At the very centre of our Milky Way there is a supermassive black hole. Now that word, black hole, it brings to mind scary images. A monster. A void that eats light, a cosmic vacuum cleaner, devouring everything that comes near it. We think of it as a thing of destruction. But let us set that fear aside. Let us breathe. And let us look at it in a new way. This black hole is not a monster. It is a founder. It is a shaper. It is the galaxy's moneo. It is the anchor. Imagine a giant heavyweight dropped into the centre of a flowing river. The water, the stars, the gas, the dust does not get sucked into the weight. It flows around it. The weight gives the river a centre, a point to circular focus for its energy. This is Sagittarius' star. It is the calm, heavy, massive centre around which the entire dance of the Milky Way takes place. It is truly massive. It has the weight, the mass of 4 million of our suns. Imagine that. 4 million stars, just like our own sun, crushed down into a single point so small it is almost zero. The gravity from this single point is what holds the central bulge together. It is the pivot for the entire galaxy. Every single star, including our own sun, far, far away, is revolving around this one central point. Our sun takes over 200 million years to make one single trip around this distant anchor. We are here at the edge looking into the darkness. We cannot see the hole itself. By its very nature it is black. Light cannot escape it, but we can see its effects. We can see the stars that live closest to it. These are the S stars. They are the ultimate thrill seekers of the galaxy. We watch in our mind's eye as one of them, a bright blue star, swings dangerously close. It is moving at an unbelievable speed, thousands of kilometers every second. It gets closer and closer to the blackness pulled in by the immense gravity. We feel a moment of tension. Will it be eaten? And then at the last possible moment, gravity acts like a slingshot. The star is whipped around the invisible point and flung back into the safety of the central cluster before it begins its long, looping journey back in again. We are watching the laws of physics pushed to their absolute limit. We are seeing gravity in its purest, most powerful form. This black hole, our anchor, is actually very quiet. In some other galaxies, the central black hole is active. It is feeding. It pulls in huge continuous streams of gas and dust, and as this material falls in, it heats up to millions of degrees and shines with a light brighter than the entire galaxy itself. These are called quasars. But our black hole Sagittarius star is sleeping. It is in a quiet phase. It is not feeding. It sits in the centre, dark and silent, its great work mostly done. Its very presence is what shaped the galaxy around it. Scientists believe that these supermassive black holes formed first, and that the galaxies then formed around them like a pearl, forming around a single grain of sand. This anchor, us, is our beginning. It is the seed from which our enormous, beautiful spiral city of stars grew. It is not a monster. It is the heart. It is the hidden, dark, mysterious, and truly powerful core that gives our entire galaxy its shape, its structure, and its motion. We float here in the imaginary safety of our ship at the very centre of it all. We are surrounded by the golden light of 1 million ancient stars, all swarming like moths around a dark, invisible flame. We are watching stars swing by at unbelievable speeds. And at the centre of it all is the calm, quiet, sleeping giant. the anchor that holds all the 400 billion stars, including our own tiny sun, in its gentle, massive gravitational embrace. It is a place of extremes, extreme density, extreme speed, extreme age, and extreme gravity, but it is also a place of stability. It is the center, the point of stillness in the middle of the cosmic dance. Take a moment. Just float here at the heart of the Milky Way. Feel the scale of it, the age of it, the power of it. Feel the connection. The gravity from this very point reaches all the way out across 100,000 light years to hold our own solar system in its orbit. We are connected. We are part of this single, vast, magnificent structure. And now slowly, gently, we turn our ship around. We leave the chaotic golden light of the central bulge. We pass back through the great dark curtains of dust and gas. We leave the crowded city of ancient stars behind us. We are heading back to the quiet, familiar, open spaces of the spiral arms, back to the neighborhood we call home. We move away from the heart, but we carry the memory of it with us. The memory of the dark, silent anchor, the moneo that holds us all together, spinning slowly in the cosmic night. Relax, breathe, and let the majesty of the galaxy's heart fill your mind with peace and with wonder. Let your mind drift, float away from the familiar starry arms of the Milky Way. We have been resting here in our home galaxy, and it feels like the entire universe. For a very long time, humanity believed this was it. We thought our galaxy was the universe. When we looked up, we saw those little fuzzy, faint patches of light in the darkness between our own stars. We called them nebulae. We thought they were just clouds of gas, maybe new star systems being born all inside our own cosmic borders. But then in the 1920s, an astronomer named Edwin Hubble used a new giant telescope to look at one of these patches, the biggest and brightest one in the constellation of Andromeda. He stared at it night after night until he saw something that changed our world forever. He saw individual stars just like the stars in our own galaxy. He measured how bright they were. He calculated how far away they must be, and the answer he found was staggering. They were not thousands of light years away, they were millions of light years away. They were not in our galaxy. That faint fuzzy patch was not a cloud, it was, as he called it, an island universe. A whole other galaxy. In that moment, the universe burst open. Our Milky Way was not the entire cosmos. It was just one island in an ocean of other islands. Billions, perhaps trillions of them. Each one a collection of billions or trillions of stars, each one a home. You can just let that feeling wash over you, the scale, the immensity. We are one island in a sea of light. And just like on any island, we have neighbours. We are not alone in this dark ocean. Our galaxy is part of a small, relatively cozy cluster of galaxies. We call it the local group. Think of it as our cosmic neighbourhood, our small village. It's about 10 million light years across and it contains more than 50 galaxies. Most of them are small dwarf galaxies like little suburbs or hamlets, quietly orbiting the main residence. There are two giants in this village, two great cities of stars. One is our Milky Way, the other is the one Hubble studied, the Andromeda galaxy. Andromeda is our sister galaxy. Our twin. It is a massive spiral, slightly larger than we are, perhaps holding 1 trillion stars. It is only 2.5 million light years away. In cosmic terms, that is our very next door neighbour. This distance is so small, in fact, that on a perfectly clear dark night far away from city lights, you can see Andromeda with your own eyes. No telescope needed. It looks like a tiny, faint, fuzzy smudge, a little misty patch of light. When you see it, you are looking at the most distant object your unaided eye can perceive, and the light from that smudge has been travelling for 2.5 million years to reach you. You are quite literally looking millions of years into the past at an entire island of stars. Feel the connection that light travelling for so long ending its journey with you. As we zoom our minds out beyond our local group, we see that these island universes are not all the same. It is a cosmic zoo of magnificent shapes and sizes. First, there are the spiral galaxies like our home and like Andromeda. They are the pinwheels of the universe. They have a bright central hub and beautiful, graceful arms that sweep outwards. These arms are where the action is. They are full of gas and dust, and they are bright blue with the fire of new young hot stars. Spirals are the active, vibrant, creative cities of the cosmos, still busy building new stars and new worlds. Then we see the elliptical galaxies. These are very different. They are not flat pinwheels, they are giant round or oval-shaped, like a glowing cosmic football or a fuzzy egg. They are smooth. They don't have those bright blue arms, instead they glow with the soft warm light of older yellow and red stars. An elliptical galaxy is like a great ancient mature city. The building boom is over. The gas and dust are mostly gone. They are quiet, settled, and ancient, holding trillions of old stars in their gentle gravitational grip. Finally, there are the irregular galaxies. These have no shape at all. They are the rebels. They are chaotic, splotchy, and disorganized like a beautiful cosmic mess. They are often bursting with new star formation triggered by some past event. Each shape tells a story. The story of a spiral is one of balance and rotation. The story of an elliptical is often one of a chaotic past, a story of mergers. The story of an irregular is one of change or youthful energy. These islands are not static, they are not fixed in the dark, they are all moving, dancing to the slow, silent music of gravity. And sometimes their dance brings them together. Galaxies interact, they brush past each other, they pull on one another. When they get close, gravity can stretch them out, pulling vast, beautiful streamers of stars and gas called tidal tails that reach across space for hundreds of thousands of light years. And sometimes they collide. This word collision sounds violent, it sounds destructive, but a galaxy collision is nothing like what you imagine. It is the slowest, most graceful crash in the universe, taking hundreds of millions of years to unfold. And galaxies are mostly empty space. The stars, the individual suns, are like single grains of sand miles and miles apart from each other. When two galaxies each with trillions of stars fly through each other, almost none of the stars will actually hit. It is like two massive swarms of bees passing through one another. The bees themselves don't touch, but the gas, the vast invisible clouds of hydrogen, they collide. And this collision, this pressure sets off a spectacular firestorm of creation. A starburst. Billions of new stars are born all at once, lighting up the merging galaxies in a brilliant display. And after the long, slow dance is over, the chaos settles. The two galaxies do not just go their separate ways, they merge, they become one. Often two beautiful spirals will merge and settle down to become one new giant, peaceful elliptical galaxy. Their story is now a shared one. This story of mergers is our own future. Our neighbour Andromeda is not just sitting there, it is moving. It is moving towards us, pulled by our shared gravity. It is racing towards the Milky Way at over 200,000 miles per hour. There is no need to worry. This is a story for the very, very distant future. In about 4.5 billion years, our sun will be an old star. And on a future Earth, if anything is here to watch, the sky will be spectacular. Andromeda will grow larger and larger, a beautiful blazing spiral filling the night. Then the two galaxies will begin their dance. They will pass through each other. Our solar system will likely be thrown into a new, wider orbit far from the chaotic center. The night sky will be illuminated by a billion new suns. Over hundreds of millions of years, the two will merge. The Milky Way and Andromeda will become one, a new giant elliptical galaxy. We can call it Milkomeda, but that's a story for a deep, deep sleep. For now, just rest in our own quiet spiral arm, and dream of the other islands, the billions of other homes floating peacefully in the great, dark, beautiful night. We have journeyed from our home planet past the fiery cauldron of our sun and beyond the familiar stars of our galactic neighborhood. We have crossed the immense spire of the Milky Way, a city of hundreds of billions of stars. But to understand the true shape of the universe, we must continue to pull back. Imagine pulling your viewpoint so far away that the entire Milky Way with its 100,000 light-year diameter shrinks to a single glittering point of light. Our giant neighbor Andromeda becomes another pinprick. The thousands of galaxies we can see with our best telescopes become a faint dusting of luminous powder. At this scale, we are no longer looking at things, we are looking at architecture. We have zoomed out to see the largest pattern in existence, the grand design of the cosmos. This is the story of the cosmic web. From groups to clusters, the megacities. Just as gravity pulls stars into galaxies, it also pulls galaxies into groups. Our own Milky Way is part of the local group, a relatively small collection of a few dozen galaxies. This is like a quiet cosmic suburb. But as we look deeper into space, we find them downtown areas, the great galaxy clusters. These are the true megacities of the universe. A single cluster can contain hundreds or even thousands of galaxies, all bound together by their mutual gravity into a relatively compact space, a space that is still millions of light years across. A perfect example is the Virgo cluster. This is the closest large cluster to us, and in fact our local group is currently being pulled toward it. It contains over 1,500 galaxies. At its heart lies a true monster, a giant elliptical galaxy named Messier 87. This galaxy is not a beautiful spiral like ours. It is an enormous round blob of ancient stars, the product of countless galactic mergers. It has eaten its neighbours to grow to its current size, and it rules the cluster's core. Life inside a cluster like Virgo is chaotic. Galaxies are not in gentle orbits. They are swarming like bees in a hive, moving at speeds of hundreds of kilometers per second. This environment is dangerous. Galaxies frequently collide, ripping each other apart with tidal forces or merging into new larger galaxies. But the stars and galaxies are not the most massive part of a cluster. Floating between the galaxies is a vast invisible ocean of superheated gas called the intracluster medium. This gas, which is the leftover material from the formation of these galaxies, is heated to millions of degrees. It is so hot that it shines brightly not in visible light but in X-rays. In fact, this gas contains more mass than all the stars in all the cluster's galaxies combined. If Virgo is a sprawling metropolis, the Coma cluster is a dense ancient capital city. It is much farther away, and even larger, containing thousands of galaxies packed tightly together. The Coma cluster is a rich cluster, and it shows us what happens to galaxies in these crowded places. You will not find many beautiful star-forming spiral galaxies like the Milky Way in the center of the Coma cluster. Instead, it is dominated by two colossal elliptical galaxies. The intense gravity and the high-speed encounters in the cluster's core tend to destroy spirals. Their delicate arms are torn off, their gas is stripped away by the hot intracluster medium, a process called ram pressure stripping, and their star formation grinds to a halt. What's left are red and dead elliptical galaxies full of old red stars. The cluster environment actively shapes the evolution of every galaxy within it. Superclusters Laniakea, our home. For a long time, astronomers thought clusters were the biggest things in the universe. But as we mapped more and more of the sky, we noticed that even the clusters themselves are not spread out randomly. They too are being pulled together. This next level of structure is the supercluster. If a galaxy is a house and a cluster is a city, then a supercluster is the entire country or continent. Our own cosmic continent has a name, Laniakea. This name comes from the Hawaiian language and means immeasurable heaven or open skies. Laniakea is enormous. It stretches for over 500 million light-years and contains the mass of 100 quadrillion 100,000 million suns. Our local group is in it. The entire Virgo cluster is in it. In total, Laniakea is the home system for about 100,000 large galaxies all moving together. What's fascinating is how Laniakea was discovered. It wasn't seen, it was felt. In 2014, a team of astronomers mapped the motions of galaxies in our part of the universe. They found that all the galaxies, including our own, are flowing like water in a river. They mapped this flow and found a watershed. All the galaxies within this watershed are flowing toward a single common point. That watershed is Laniakea. And what are we flowing toward? We are being pulled toward a gravitational anomaly, a drain at the center of our supercluster's basin. This point is called the Great Attractor. It is a region of space with an immense concentration of mass, so large that its gravity is winning the tug of war against the expansion of the universe, pulling in everything for hundreds of millions of light years. We are currently moving toward it at over 600 kilometers per second. We cannot see the Great Attractor directly because it is hidden from our view by the dense gas and dust in the disk of our own Milky Way galaxy, a region called the Zone of Avoidance. Laniakea is a staggering structure, but it is not bound like a cluster is. The force of dark energy which is pushing the universe apart is so strong over these vast distances that Laniakea will likely never pull itself together into a single dense object. It is a grand temporary gathering in the cosmic ocean, the cosmic web, the big picture. Now we zoom out one last time. We pull our view back so far that even Laniakea is just one part of a larger pattern. What we see is the ultimate structure of the universe. It is not a random collection of superclusters. Instead, the universe is organized into a vast, shimmering three-dimensional network. It looks like a sponge or a biological neural network or a spider's web. This is the cosmic web. This structure consists of two main parts. The first are the filaments. These are unfathomably long, thin bridges and walls that connect everything. They are the threads of the web. These filaments are like cosmic superhighways, and they are made almost entirely of invisible dark matter. This structure was not a surprise. When scientists run computer simulations of the Big Bang, they start with a nearly uniform soup of matter and dark matter. They let gravity run its course for 13.8 billion years. Every single time this web is what forms. Gravity is an amplifier. The regions that started with just a tiny bit more dark matter than average began to pull in material from their surroundings. This matter flowed in, leaving other regions empty, and formed these long stringy structures. The normal matter, the gas and dust that makes stars and galaxies, is like the luminous dew that has condensed onto this invisible web. Galaxies do not form in random places. They are born inside these dark matter filaments. The filaments funnel gas and galaxies along their length, guiding them like rivers until they reach the intersections. These intersections where several filaments meet are the nodes of the web. This is where matter becomes most concentrated. And that is what a galaxy cluster is. The great clusters like Virgo and Coma are the massive bustling cities built at the junction of the largest cosmic highways. The voids. The great silence, a web is defined just as much by its empty spaces as by its threads. If the filaments and clusters are the bright, noisy, crowded parts of the universe, the second part of the cosmic web is the great silence, the voids. The voids are the vast oceans of near emptiness that the filaments stretch across. These regions are colossal, spanning hundreds of millions of light years. As gravity pulled matter into the filaments, it was simultaneously emptying out these other regions. They are not perfectly empty. A large void might contain a few tiny, isolated, dwarf galaxies wandering alone in the dark, but for the most part they are breathtakingly barren. The prompt calls this the Great Silence, and that is the perfect description. If you lived on a planet in a void galaxy, your night sky would be almost completely black. You would see the stars of your own small galaxy, but the great beacons of light like Andromeda or the Virgo cluster would be missing too impossibly far away to see. These voids are not just passive, they shape the universe. The structure of the cosmos is this stark contrast between the dense matter-filled filaments and the vast empty voids. We ourselves live in a telling location. The Milky Way is not in a dense cluster, nor is it in the middle of a void. We are on the very edge of one. Our Laniakea supercluster forms a great wall of galaxies, and on the other side of us lies the vast local void. This is why when we look in the direction of the Virgo cluster, we see a sky thick with galaxies, but when we look in the opposite direction, the universe seems much emptier. We are standing on the shore of a great cosmic ocean of nothingness. These voids are also the key to understanding the greatest mystery in science. While the clusters are dominated by gravity and dark matter, the voids are dominated by dark energy, the mysterious force that is causing the universe to expand at an accelerating rate. Because there is so little matter in the voids to counteract it, dark energy's push is the main force at play. This then is the grandest picture, a universe of structure built from an invisible scaffolding of dark matter, where galaxies trace luminous filaments across silent voids, and all of it is being slowly stretched apart by the dark energy in the emptiness. This is the cosmic web, the fundamental architecture of our reality. Welcome back, fellow traveller. We have journeyed so far together. We have walked on the surfaces of strange worlds, we have felt the pull of neutron stars, and we have respectfully skirted the edges of black holes, the universe's great mysteries. We have looked at the small and we have looked at the vast, but now we come to the two greatest questions of all, the questions that human beings have asked since the very first time we looked up at the night sky and truly wondered. Where did all of this come from, and where is it all going? Tonight we drift into the realm of cosmology, the study of the entire universe, its birth, its life, and its eventual distant end. Let these thoughts not be heavy. Let them be a vast cosmic blanket settling over you. Let the sail of it all dissolve your smaller worries. There is a deep peace in contemplating the absolute. So let your mind relax, let your body feel heavy and supported, and let us look at the beginning and the end. The first great realization we must have is that the universe is not static. It is not a fixed, eternal stage on which the drama of stars and galaxies plays out. The universe is alive, it is a process, and the primary thing it is doing is growing. The universe is expanding. Imagine this for a moment. The space between all things is stretching. It's not that the galaxies are flying through space away from each other, like pieces of shrapnel from an explosion. It is the space itself that is expanding, carrying the galaxies along with it. A simple way to picture this is to imagine a loaf of raisin bread dough rising in a warm oven. As the dough space expands, it pushes all the raisins' galaxies farther apart from each other. If you were sitting on one raisin, it would look like every other raisin is moving away from you. The farther away a raisin is, the more dough there is between you and it, and so the faster it appears to be moving away as the dough expands. This is exactly what we see. Around 100 years ago, astronomers like Edwin Hubble looked out at the distant galaxies. He expected to see a random mix, some moving toward us, some moving away. Instead, he found something profound. Almost every single galaxy in every direction is moving away from us. And the farther away they are, the faster they are speeding away. This was the first clue. The universe is growing. How do we know they are moving away? We look at their light. Light travels in waves. When an object moves toward you, the waves of light get squashed together, shifting to the blue end of the spectrum. When an object moves away from you, the light waves get stretched out. When light is stretched, it becomes redder. We call this the cosmic redshift. It's just like the sound of an ambulance siren. As the siren comes toward you, the sound waves are compressed and the pitch is high. As it passes you and moves away, the sound waves are stretched and the pitch drops low. When we look into the deep cosmos, we hear this low-pitched sound in light. We see red. Everywhere we look, the light from the distant galaxies is stretched, shifted toward the red. They're all moving away. The universe is without a doubt expanding. This one simple fact changes everything. Because if the universe is expanding now, it means that in the past it must have been smaller. If we are expanding, then we can run the movie of the cosmos in reverse. We can rewind time. If we do this, we see the galaxies currently vast distances apart begin to rush back toward each other. The stretching of space becomes a compression. The universe in the past was more crowded, it was denser, and as anything does when it's compressed, it was hotter. We rewind back past the formation of our own Earth just over 4 billion years ago. We rewind past the birth of the first stars. We go further and further. The universe gets smaller, denser, and hotter. We keep rewinding for 13.8 billion years. We reach a point where all the matter, all the energy, all the galaxies, all the stars, all the planets, all of us, everything we can see and everything we cannot, was compressed into a single point, a point of almost infinite density and unimaginable heat. A state so hot and so dense that our laws of physics, our understanding of space and time simply break down. We cannot see beyond this point. This is the beginning. We call it the Big Bang, but this name given by an astronomer who meant it as an insult is wonderfully misleading. It was not a bang. It was not an explosion in space like a bomb going off in a dark empty room. It was the explosion of space. There was no before, because time itself began in that moment. There was no outside, because space itself was created in that moment. The Big Bang was not an event in the universe. It was the universe. It was the sudden, rapid expansion of space-time itself from a single hot, dense point into the cooling, growing cosmos we know today. From that one moment 13.8 billion years ago, the universe began to expand and it began to cool. And in that cooling, all the complexity of our world became possible. The universe began. If this story is true, if the universe really did begin in an unimaginably hot, dense flash, then there should be some evidence left behind. There should be an afterglow, a residual heat lingering from the inferno of creation. For a long time we looked for it, and then we found it. In the 1960s, two scientists, Arno Penzias and Robert Wilson, were working with a large radio antenna trying to get a clear signal. But they were plagued by a persistent faint background hiss, a noise that came from every direction day and night no matter where they pointed the antenna. They thought it might be pigeon droppings. They cleaned the antenna, the hiss remained. What they had found was not an annoyance. It was the echo of the Big Bang. Let us go back to the young universe. For the first 380,000 years, the cosmos was not empty and dark. It was a brilliant, blindingly hot, opaque fog. It was so hot that atoms could not form. Electrons and protons were separate, creating a plasma that scattered light. Light could not travel freely. It was trapped, bouncing around inside this cosmic fog like light inside a dense cloud. But all this time the universe was expanding, and as it expanded it cooled. Then after 380,000 years it crossed a threshold. It became just cool enough for the protons and the electrons to find each other, to recombine, and to form the first stable atoms, mostly hydrogen and helium. Suddenly the fog cleared. The universe became transparent, and all the light that had been trapped inside that fog was suddenly set free, unleashed to travel across the cosmos uninterrupted for the first time. That light, the first light to ever travel freely, is still traveling. It has been traveling for 13.8 billion years, and as it traveled, the universe continued to expand, stretching that light. What was once a brilliant white-hot glow has been stretched and stretched and stretched, all the way down into the microwave part of the spectrum, invisible to our eyes, but detectable by radio antennas. This is the cosmic microwave background. It is the light from the universe's first sunrise. It is the oldest light we will ever see. That faint hiss that Penzias and Wilson found is the sound of creation. It is the residual warmth, the echo of the Big Bang filling every single cubic inch of space. When you feel lost or small, remember this: you are bathed at this very second in the faint, ancient leftover light from the moment the universe was born. So we have a beginning, a hot, dense, brilliant beginning, and we have a present, a cool, expanding, star-filled present. But what about the end? This is the final question. If the universe had a birth, will it also have a death? The fate of the universe is a grand battle between two forces. On one side there is gravity, the force that pulls everything together. On the other side there is the expansion, the force that pushes everything apart. For a long time we thought there were two options. If gravity was strong enough, it would eventually win. The expansion would slow down, stop, and then reverse. The universe would fall back in on itself, ending in a big crunch, a fiery reversal of the Big Bang. Or if the expansion was strong enough, it would just barely overcome gravity and the universe would expand forever, but slower and slower, just coasting. But in the 90s, we discovered something that no one expected. We aimed our telescopes at distant supernovae exploding stars to measure how much the expansion was slowing down, and we found it wasn't slowing down at all. It's speeding up. The expansion of the universe is accelerating. Something is pushing everything apart faster and faster and faster. It is an anti-gravity force that we do not understand. It seems to be a property of empty space itself. We have given it a simple, humble name for something so powerful: dark energy. This discovery has written our future, and it points to a very different kind of end. It's not an end of fire, but an end of ice. It is called the Big Freeze. It will not be sudden. It will be the slowest, most gradual fade in history. As the expansion accelerates, the distant galaxies will be pushed away from us so fast that their light will be redshifted into nothingness. One by one, they will disappear from our view. The night sky will become dark and empty beyond our own local group of galaxies. Then we wait. Trillions of years will pass. The gas in our remaining galaxies will be used up. The great, beautiful nebulas will fade. Star formation will stop. The universe will run out of fuel. The stars we have will begin to go out. The great bright blue stars die first, then the yellow stars like our sun. Finally, only the tiny dim red dwarf stars will remain sipping their fuel for trillions of years. But eventually the last red dwarf will sputter and cool and die. The last light in the universe will go out. The universe will enter an age of true darkness. All that will be left are the cinders, cold dead planets, brown dwarfs, neutron stars and black holes. And even they are not forever. Over timescales so vast they make the current age of the universe seem like a heartbeat. Even the black holes will evaporate, dissolving into a faint whisper of radiation. The universe will continue to expand and continue to cool. It will become a vast, silent and empty expanse. The temperature will drop, approaching but never quite reaching absolute zero. All motion will cease. All thought will cease. The universe will end not with a bang, but with a long, slow, cold and perfect equilibrium, a final, peaceful and unchanging darkness. This is the Big Freeze. Hum fades back in gently. Do not let this thought disturb your rest. This end is not for us. It is not for our children, or for our planet, or for our sun. The time until the last star fades is so long that our 13.8 billion year history is just the first bright, hopeful intake of breath. We are living in the glorious, brilliant morning of the cosmos, the saliferous era, the age of stars. We are here now while the universe is young and warm and filled with light. We are the product of that first hot beginning. We are made from the ashes of stars that lived and died before us, and we are the witnesses here for just a moment to look out and understand this vast, grand, beautiful and temporary story. You are a part of this story, from the first expansion to the first light to the final quiet cold. You are the universe becoming aware of itself, so rest. Let the vastness of these timelines hold you. You are safe in this moment. You are part of the grand cosmic unfolding. From the first fire to the final ice. Imagine for a moment that you are standing on the shore of a vast dark ocean at night. You have a single small flashlight. You point the beam at the waves lapping at your feet. You can see the sand, the shimmering foam and a few small shells. You study them, you categorize them, you understand them. You feel proud, you feel. You understand the beach, but then you turn the flashlight off and you look up. You see no moon, no stars, you see only darkness. And you hear the sound of the ocean, a colossal thundering presence that stretches out before you, so vast it seems to go on forever. You realize that your flashlight only showed you the tiniest, most insignificant fraction of what is really there. The sand and the shells are not the main thing, the ocean is the main thing. This is the situation humanity finds ourselves in today. Everything we have ever seen, every star we have ever named, every planet we have mapped, every galaxy we have photographed, all of it is just the foam on the waves. All the normal matter, the atoms that make up you, me, the Earth, and all the stars accounts for only about 5% of the universe. The rest, the other 95%, that is the dark ocean. It is a reality that surrounds us, permeates us, and dictates the entire shape and future of our cosmos. Yet we cannot see it, we cannot touch it, we cannot catch it in a bottle. We have only just begun to hear its sound, to sense its awesome presence. This is the great unknown, the dark universe. It is not empty and it is not evil. It is simply hidden, and it is made of two separate, equally baffling components, dark matter and dark energy. The cosmic ghost dark matter. Let's first talk about the scaffolding of the cosmos, the part we call dark matter. This invisible substance makes up about 27% of the universe. It is the first and perhaps most humbling piece of the puzzle. We discovered dark matter not by seeing it, but by seeing what it does to the things we can see. The story begins in the 1970s with an astronomer named Vera Rubin. She was studying galaxies, specifically the speed at which stars rotated around the galactic center. Logic and our laws of gravity from Newton and Einstein predicted something very simple. Stars closer to the bright dense center should move quickly, while stars on the outer edges should move slowly, like an ice skater slowing down as they extend their arms. What she found was shocking. The stars on the outer edges were moving just as fast as the stars near the center. In fact, entire galaxies were spinning so fast that if the only gravity holding them together was from the stars and gas we could see, they should have torn themselves apart, flinging their stars into the empty void ages ago. They were not flying apart, they were stable. The only way this is possible is if there is more stuff, more mass. A lot more mass. There must be an enormous invisible halo of something weighing the galaxy down, providing the extra gravity needed to keep those fast-moving outer stars in their orbits. It's like watching a group of children holding hands and spinning in a circle. If they spin too fast, their hands slip and the circle breaks. But if a dozen invisible adults are standing in the circle holding their hands, the children can spin much faster without flying away. That invisible something is dark matter. We call it dark, not because it is scary, but because it is completely transparent to light. It does not shine, it does not reflect, it does not block or cast a shadow. Light, radio waves, X-rays, they all pass right through it as if it isn't there. It is the ultimate ghost. In fact, trillions of dark matter particles are likely streaming through your body through the entire Earth right now, and you do not feel a thing. So how do we know it's there? We watch for its gravity. One of the most beautiful and strange ways we see dark matter is by using a trick of Einstein's called gravitational lensing. Gravity is not just a pull, it is a curve in the fabric of space and time. A massive object like a cluster of galaxies or a big clump of dark matter bends the space around it. When light from a more distant galaxy travels past this clump, its path is bent like light passing through a magnifying glass. When we look at the deep universe with telescopes like the Hubble, we see this all the time. We see images of distant galaxies that are smeared, stretched into long, beautiful arcs, or even duplicated, appearing in several places at once. We can calculate the mass of the visible stars in the magnifying glass and see that their gravity is not nearly strong enough to create such a distortion. The only explanation is a massive invisible concentration of dark matter acting as the true cosmic lens. So what is it? This is the central tantalizing mystery. We know what it is not. It is not us. It is not made of protons, neutrons, or electrons. It is not part of the normal family of particles. For decades, the leading idea has been a new type of particle, something our best theories predict but we have never found. These are nicknamed WIMPs, or weakly interacting massive particles. They would be heavy, slow-moving, and, as their name suggests, almost completely antisocial, interacting with our world only through gravity and perhaps one other fundamental force we haven't found. Scientists have built enormous experiments to find them. They have gone deep underground to the bottom of old mines or under mountains to shield their sensitive detectors from all other cosmic noise, and they have waited patiently for a single telltale ping, the sound of a dark matter particle bumping into a normal one. So far, silence. The ghost remains elusive. It's also possible that our entire theory of gravity is slightly wrong. Perhaps on the scale of galaxies, gravity just works differently and there is no dark matter at all. This is a less popular idea, but it shows how little we truly know. Dark matter is the invisible framework, the silent architect of the cosmos. The normal matter, we see the galaxies themselves, are just the bright spots of foam that have collected in the deepest pools of this vast dark structure. The runaway universe. Dark energy. If dark matter was a humbling mystery, dark energy is a terrifying one. It is the deep underlying current of the ocean, the force that controls the ultimate fate of everything. It is also the biggest component of the cosmos, making up an estimated 68% of all the stuff in the universe. To understand dark energy, we have to go back to the 1990s. For decades, cosmologists had a clear picture of our universe's future. We knew from the work of Edwin Hubble that the universe was expanding, galaxies were moving away from each other, like raisins in a baking loaf of bread. But we assumed the combined gravity of all the matter in the universe, both normal and dark, must be acting as a brake. It should be slowing the expansion down. The biggest question in cosmology was, is there enough stuff to stop the expansion and cause it to collapse back in on itself, a big crunch? Or will it slow down but expand forever? Two separate teams of astronomers set out to measure this slowdown. Their plan was to use a special kind of exploding star, a type Ia supernova, as a tended Talmud candle. These explosions are so bright they can be seen billions of light years away, and they all explode with almost exactly the same brightness. This means that if you see one that looks dim, it must be very far away. If it looks bright, it must be close. They pointed their telescopes into the deep past, looking for these supernovas in distant galaxies. They measured their dimness, their distance, and their redshift, how fast they were moving away from us. They collected the data, they checked their math, and they were stunned. The distant supernovas were dimmer than they were supposed to be. They were farther away than all the models predicted. The only way this could be true is if the expansion of the universe was not slowing down. In fact, for the last 5 billion years or so, it has been speeding up. This was a discovery that changed everything. It was like throwing your keys up in the air and watching them accelerate into the sky faster and faster until they disappeared. Something was pushing the universe apart. Something was acting as an anti-gravity, a repulsive force that was winning the cosmic tug-of-war against the gravity of all the dark matter. They gave this something a name, a placeholder for our ignorance: dark energy. Unlike dark matter, which is a thing, a particle we think that clumps together to build structures, dark energy seems to be a property of space itself. It is a thin, invisible energy that exists in every single cubic centimetre of empty vacuum. And it has a very strange property: as the universe expands, it creates more space. And this new space comes with its own new dark energy, so as the universe gets bigger, the push gets stronger. Gravity pulls things together. Dark energy pushes them apart. In the early universe, which was small and dense, gravity was king. Dark matter pulled the universe together into the beautiful web of galaxies we see today. But as the universe expanded, all that matter got diluted, spread further and further apart. The pull of gravity got weaker. The dark energy, however, did not. Its strength is constant in space. As more space was created, the total push of dark energy began to overpower the total pull of gravity. About 5 billion years ago, our universe passed a tipping point. The accelerator was pressed harder than the brake. What is this energy? The simple, honest answer is we have absolutely no idea. One possibility is that it is the cosmological constant, an idea Albert Einstein had, and then famously called his biggest blunder. He imagined an energy inherent in the vacuum of space itself. Our best theories of particle physics predict such an energy, but when we try to calculate how strong it should be, the number we get is baffling. It is 120 orders of magnitude, that's A1 followed by 120 zeros larger than the gentle push we actually observe. Our theory is disastrously, wildly wrong. This is the frontier. This is the edge of human knowledge. Dark energy is the ocean itself, a vast uniform presence that is slowly, inexorably pushing all the islands, the galaxies away from each other. The beauty of the unknown. And so we are left in this quiet, mysterious place. We stand on our tiny shore of 5% reality. We know that just beyond the light of our flashlight there is a 27% ghost of dark matter holding our galaxy together, and a 68% force of dark energy pushing our future away from us. This is not a failure of science. This is its greatest triumph. It is the moment we have become wise enough to recognize the true scale of our own ignorance. There is a profound humility in realizing that we are not just small, but we are made of the rare stuff. We are the exceptions, the foam, not the rule. The dark universe forces us to ask the biggest questions. What is reality? What is the fate of the cosmos? If the expansion continues to accelerate, a dark future awaits. In billions of years, all the other galaxies will be pushed so far away so fast that their light will never be able to reach us. They will vanish from our night sky one by one. The universe will become a dark, cold, and profoundly lonely place with our own Milky Way left as a single isolated island in an endless empty void. This is the beauty of a mystery left unsolved. It is a puzzle given to us by the universe itself. It reminds us that no matter how much we learn, there is always more to wonder about. We are not at the end of discovery. We are perhaps for the first time finally aware of the beginning. We are the children standing at the edge of the dark ocean under a vast, unknowable sky, and we have just started to ask the right questions. And so our long journey through the cosmos across billions of years and light years of space finally comes to an end. We have travelled from the first moments of creation to the edges of the known universe, witnessing the birth and death of stars, the silent dance of galaxies and the deep mysteries of the dark. And now we return. We float back from the vast and the distant, back to the familiar, back to the here and the now. We return home. But where is this home? It is not just a building or a city. It is right here in this room, in this moment. We return to you. Because you see, this entire journey has not been about something out there, something separate from yourself. The most profound truth is that you are not just living in the universe is living in you. Think for a moment about the very atoms that make up your body. The iron in your blood, the calcium in your bones, the carbon that forms the basis of every cell. Where did they come from? They were not here at the beginning of time. They were forged. Billions of years ago, a star far more massive than our own sun lived its life. For millions of years it burned in the darkness, and in its core, in its immense fiery furnace, it fused lighter elements into heavier ones. It created oxygen. It created carbon. It created iron. And when that star reached the end of its life, it died in a spectacular explosion, a supernova. In its final magnificent burst of light, it scattered these precious newly formed atoms across the galaxy like a farmer sowing seeds in a vast dark field. Over eons, that dust, that stardust, drifted through the emptiness of space. It gathered together, drawn by gravity, into a new cloud of gas and dust. That cloud collapsed, and from it our sun was born. Our planet, the Earth, was born. And from the material of this earth, life was born. You are in the most literal and physical sense made of stardust. You are the ashes of long-dead stars given life, given breath, and given time. The atoms that are you have been on a journey lasting for over 13 billion years. You are a child of the cosmos. When you look up at the night sky, you are not looking at something foreign. You are looking back at your own ancestral home. But you are more than just the physical material. You are more than just a collection of atoms. In all the vastness of the universe, in all its penetrant swirling beauty, something truly magical happened. On this small blue-green planet that stardust learned to think, it learned to feel, it learned to wonder. This is perhaps the most incredible realization of all. You are the universe becoming aware of itself. For billions of years, the cosmos existed in a state of magnificent unconscious beauty. The great nebulae could not appreciate their own vibrant colours. The spinning galaxies did not know they were dancing. The stars did not know they were shining. And then a part of that universe, that same recycled star stuff, organised itself into you. Your eyes are the eyes of the cosmos finally seeing the light from those ancient stars. Your ears are the ears of the cosmos hearing the sound of the wind and the ocean. And your mind, your consciousness, is the mind of the cosmos attempting to understand itself, to ask questions about its own mystery, its own purpose, and its own beauty. All of your thoughts, your dreams, your capacity for wonder, that is the universe experiencing itself. You are not just a spectator separate from the show, you are the show. With this understanding, it is easy to feel small. We stand on a tiny planet orbiting an average star in a quiet neighbourhood of a galaxy that is just one of hundreds of billions. Our lives are fleeting, a momentary flicker in the grand expanse of cosmic time. But this feeling of smallness is not a reason for fear or for sadness. It is the very source of our connection. To be small means you are a part of something truly magnificent, something so much larger than yourself. You are not an isolated being separate from the whole. You are a thread woven perfectly into a grand and infinite tapestry. Your smallness is what connects you. It connects you to the ground beneath you, to the air you are breathing, and to every other living thing. It connects you to the sun that warms you, and to the stars you see in the sky. You are not lost in the cosmos. You are part of the cosmos. You belong here just as much as any star or any galaxy. Your existence is not an accident. It is a fundamental and beautiful expression of the universe itself, and in that realization there is a deep and profound peace. You don't have to carry the weight of the world. You are simply one small, precious part of a story that has been unfolding for nearly 14 billion years. Your job is not to understand everything. Your job is simply to be. And so as our long journey ends, we find ourselves right back where we started. Here, now, in this quiet, safe and peaceful moment, you are home. You are the universe made of stardust thinking about itself. You are small, and because you are small, you are connected to everything. You are a precious, temporary and beautiful part of a grand and ongoing story. There is nothing left to do tonight. No more problems to solve, no more journeys to take. You have seen the wonders of creation, and now it is time to rest. Feel the peace that comes from this connection. The peace of accepting your place in the universe. You're safe, you are whole, and you are deeply connected to all that is, all that was, and all that ever will be. Let your mind relax. Let go of the thoughts of the day. Feel the gentle, heavy pull of sleep. It is as natural as the orbit of a planet, as peaceful as the silent darkness between the stars. Allow yourself to drift. Allow your consciousness, that brilliant spark of the cosmos, to rest, to recharge and to dream. Let the silence of deep space be your blanket. Let the gentle, steady rhythm of your breathing be your lullaby. Rest well, child of the stars. Good night.